Hello students, today we are moving to new chapter, that is multi-threaded programming. Before we directly jump into how to write on the multi-threaded programming, we need to have a clear basic understanding of prerequisite. So I'm going to cover it up. So these are the list of topics that I'll be covering to this session. So quickly going through the difference between the program and a process, right? Okay, so what is the difference between a program and a process, right? Suppose whenever you write down any program, say for example, I write down a very simple program, void main, right? So that will display the void main, that will display the message, okay? So to do that, what we do is that we write void main, because from there we'll start the main functions. Execution start from that location, so, and we'll write this is my first program. So that's what you generally do, okay? So you have got the program hash include hash include stdio dot h. Okay, so this is the program. Okay, so that will display the message. Okay, so this is the program that will display the message. So I'm assuming that you have saved this program using hello.c. Okay, now you will save this program. Okay, after writing this, what you will do, you will save the program. So when you save the program, okay, this program will be stored into the hard disk, right? It will be storing into the hard disk HDD. Now you'll compile the program using the command gcc, something like that, and an object code will be created. So with reference to Unix system, I'm saying that object code that has been generated, say for example it's a.out. Okay. So that a.out will be stored into the again hard disk. Now after that, you give the command to execute, you give the command dot slash, okay, a.out. so dot slash is the execution command, and a.out is the name of the object code. Now when you give the command dot slash a.out, this object code will be loaded into the RAM, random access memory. Okay, so in the RAM it will get loaded and will get executed. That's the general procedure of writing the program, compiling the program, and execution. Now during this entire process, okay, whenever during this entire process, so till a.out, this set of instructions are the program, or pertains to program. Now when this program gets transferred into the executable mode, whenever it is stored in the RAM, at that point of time that program will become a process. So basically program is the set of instruction that is stored in the memory, and it is an passive entity. Passive, PASSI, it is a passive entity. However, when the same program is loaded into the computer memory RAM for execution, then it becomes active. Okay, so that's why it's called active entity, right? So program is an passive entity, and process is an passive entity. So that's the difference between a program and a process. Okay, so program contains a set of instructions written to perform a certain designated task, whereas the process is the program under executions. So it is an active entity. Process is an active entity because it is now performing in the RAM some task, right? However, the program are the instruction that is stored in the memory, right? It is not active. No one is executing it, or nobody is following that instruction right now. So that instance, that's why it's called passive entity. I hope I had made clear the difference between the program and a process. It's a very important topic. Now, a program is also known as a single-threaded program. A single-threaded program. Why? Because suppose there are some instructions before this printf, maybe here or after this here. So whenever the program executes, or whenever this program is in process state, then first instruction will get executed. Okay, this is first instruction executed, second instruction will get executed, third instruction will get executed. Okay, so since main is the starting location for program execution, so whatever instruction is there after, immediately after the main function, that statement will get executed, then the remaining statement will get executed in sequence, right? So that's why it's called single threaded program, because immediately whatever that you write immediately after this curly braces, suppose it's an executable instruction, so this statement will get executed, so that's why we call it as a beginning of the program. Then after that we have rest of the instruction. Those are the sequence of instruction that will get executed one after another, and at the end there will be a last statement, that's called the end of the program. Okay, so that's how a program gets executed. That's how a single threaded program gets executed. Okay, so but our chapter name is multi-threaded program. We are not interested in the single threaded program. We already know. Okay, some of the examples of the C program are the single threaded program. Okay, so this is first a prerequisite that we need to know, that is the difference between the program and a process. Now we'll talk about the difference between single processor system and multi-processor system. Okay, so what do you mean by single processor system, and what do you mean by multi-processor system? So in a single processor system, okay, in a single processor system, you have only one process. So you have only one processor. In case of multi-processor system, you have got multiple CPUs. You have got only, in this case, you have got only one CPU. In single, you have got only one CPU. Whereas in multi, you have greater than one CPU. Okay, CPU. Nowadays, you can see in your normal computers and all, you have a Core 2 Duo, okay, or quad core. Say for example, if it is a quad core, then there are 4 CPUs. Otherwise 2. Octa means 8. There are 8 CPUs. Now suppose there are 2 CPUs in your computer, then this CPU and this CPU can execute the instruction parallelly. Okay, so the main difference between single processor and multi-processor system is that single processor system has only one processor, so it can execute only one instruction at a time. However, in case of multiprocessor system, it has got multiple CPUs, so those multiple CPUs can execute multiple instructions parallelly at the same time. Okay. So in this example, you can see that there are, since in this example, suppose I am assuming that this is a CPU. Okay, there are two CPUs. This system, this is two CPU. So there are two instructions that are being executed parallelly. So that is possible in case of multiprocessor system. You want to execute two instructions at the same time. If you want to have 4 instructions at the same time, then you will have 4 CPUs. Okay, I am talking about computations, not the input and output. So there is a difference between the computations and input-output operations. So single processor has the ability to execute only one instruction at a time. Okay. Now we'll talk about multitasking system. So right now we have talked about multi-processor system. Now talking about multitasking system. So in case of what is multitasking? By the way, multitasking is the process of executing multiple tasks simultaneously to utilize the CPU. For example, I'll give a very good example. Okay, suppose this is our timeline. This is our timeline. Okay, so here it's a time. Okay, TIME. If you go in this direction, time will always increase. And there is a program P. Okay, and there is a program P which has got some certain list of instruction to be executed by CPU. And say for example, the first statement is your statement something like computations like C equals to A plus B, and number 2 is something like input and output operation to read the data from the user or to display the data from the into the output device. Okay, suppose at time, this is time 0. Okay, I'll just mention this is time 1, this is time 2, this is time 3, and this time 4, like that. Okay, it will go on. Now suppose at time 1, okay, at time from here to here, okay, CPU is executing C equals to A plus B. Okay, CPU is executing C equals to A plus B. C equals to A plus B. Now from here CPU has to execute some other kind of instruction, maybe an IO operations, maybe an IO means input and output operations. Maybe it has to read or write operation to or from the keyboard or the mouse. Okay, so now during this time, during this time, CPU is not executing any kind of task. CPU is not executing any kind of task. So because IO operation does not involve CPU, IO operation does not involve CPU. Whereas C equals to A plus B, computational task, it involves CPU, right? So now during this time, why we can't utilize the CPU for some other task, right? That is possible. I would like to give you the example for the same multitasking, another example also, but as of now, so within the same time frame I can execute multiple tasks, right? So that's the meaning of multitasking. So here in this example, it's just an example, okay? In a time multiplexed fashion, I have executed or I have performed two tasks at the same time within a same time frame. So from here to here, the system was handling some IO activity. So in order to use the CPU maximally, I have used this time to perform some other computation, maybe x equals to y plus z. Okay, so that kind of processing is known as a multitasking or processing. Okay, so there are two different kind of multitasking that you can perform, process based and thread based. So during the while performing the multitask, it is very important for us to understand the it is very important for us to identify the set of independent computational statement for executing the simultaneous instructions, right? So I'd like to give you the example for the same. Suppose, I hope you all of you remember how does this matrix multiplication works. Okay, suppose there is a matrix. Okay, so there is a matrix. So there is two matrix, one is A and another one is B. You have to multiply. Okay, one is A and another one is B, and you have to multiply A and B. So in A you have got value 1, B here this 2, and this is 2, and this is 1, and this is 2, this is 3, and this is 3, and this is 2. Okay, so these are the values inside the matrix. Now you want to perform matrix multiplication. So how do you do it? Row into column, right? That's the basic procedure. So how do you do it? You multiply this item with this item. Okay, say for example the answer is P, okay, plus then this item into this item plus, okay, say for example, and the answer is Q. Okay, so whatever is the answer, that is Z. Okay, this is the result. Suppose this is my resultant matrix, so in this location I'll have the value Z. Okay, I repeat, suppose there is two matrix A and B with 1 2 2 1 and B 2 3 3 2 respectively, and you have to perform the A into B matrix multiplication. So matrix multiplication means you have to perform row elements into column elements of another, okay, array. So 1 into 2, say for example answer is P, plus 2 into 3, say for example answer is Q. So you add this P and Q, suppose the answer is Z, so Z will be initialized in this. So this is the resultant, C equals to A plus B, A into B, A into B. So now this is the way with which you need to perform. Now to calculate the value of this cell, it has no role. Similarly, to calculate, it has no role of this cell, it has no role of this cell, it has no role of this cell. Okay, so that's how you have to identify independent computational activities. So to calculate, I repeat, to calculate the value of this cell, this cell does not play any role. So that's the meaning of independent computational statement. So identifying such kind of statement is very very important and crucial to perform the multitasking. Okay, I hope I had made clear. So matrix multiplication is one of the very very good example for giving the for explaining the multitasking task. Okay. Next is the process. Okay, so this matrix multiplication can be performed using multitasking programming. Okay. So we have two different kind of multitasking. One is the process based, and the one is thread based. Right? So in case of process based, okay, what is the meaning of process based? So in case of process based, it saves the address memory. It saves the processes processor. Okay, it is also known as a heavyweight process, and the cost of communication between the processes is very very high. Okay, and also it is very very important that whenever whenever the CPU while executing instruction in process based multitasking switches from one process to another process, okay, some time is used wherein that in that time CPU is not utilized. Okay, that time is known as a context switch time. So I repeat, during the process-based multitasking, the program have its own address, own processor, and the process is known as a heavyweight, and the cost of communication between the process is high. So why it is high? Because there is some time required to switch from one process to another process, and that time is known as a context switch time. Next is the thread-based multitasking. See, in thread-based multitasking, memories and other resources like bus are shared. Okay, and this kind of programming is known as this kind of process or this kind of instruction are known as a lightweight process, and the cost of communication between the thread is low as compared to process. So although it requires some time, but the comparative it's less. Okay. Now, so this is all about the multitasking. So we are from a single processor to multiprocessor. We have switched to multitasking, and inside multitasking we have a process based and thread based. We have seen process based is not as much useful as or as not as much that efficient as thread based. So again, further classification of thread based, multi-threaded. So as our whatever the name of the chapter is. Okay. So now what is the meaning of thread based? Okay, what is the meaning of multi-threaded programming? So one multi-threaded programming is very very unique property of the Java, and it is very very strong feature of the Java, and that increases the efficiency while executing the program instructions. So what do you mean by multi-threaded programming? So in case of multi-threaded programming, you have got multiple flow of control. Okay, multiple flow of control. Like for example, um, in this example, you can create four threads. So one red color thread, one green color thread, one blue color thread, okay, and another one is black color thread. So you can assign the red color thread to calculate the value of, you can assign the red color thread to calculate value of this cell. Then you can have another thread, green color thread, okay, to calculate the value of this cell. Then you can have another thread to calculate the value of this cell. Blue color thread you assign to this thread, then for this cell, okay, and for black color thread you assign to this cell for calculating its value. So you in this you can see, you have seen that there are four different threads that you have used. There are four different threads you have used, and all these and all these threads will work parallelly. Okay, now if it would not had been a possible a multi-threaded, it would not had been a possible, suppose for calculating first thread, okay, first cell, suppose the time required is 2 units, so you have to spend 4 units. Okay, so 2 into 4 is 8 units of time is required to 8 units of time is required to calculate the values of first cell. But if you have the if there is a flexibility for working with the multi-threaded program, then you need only 2 units because all of them will execute parallelly. So within the same 2 unit of time, 4 will run parallelly and calculate the values and initialize in respective locations. So that's the power of the multiple flow of control. Okay, so we'll deal with it. Okay, how to write on the multi-thread program. So first of all, we'll try to understand how to what is a thread. Okay, so thread is basically a lightweight process, a small tiny program or a module that runs in parallel with other threads, right? Not other program that runs in parallel with other program, just like the way that I've shown you over here: red color thread, green color thread, blue color thread, and black color thread for this cell, this cell, this cell, and this cell respectively, right? Okay, so it contains multiple flow of control. So the threads run in parallel for executing the instructions, and while executing the instruction, they share the computer resources like memory, like bus, etc. Okay, so and they are also known as a lightweight process, which I already told you. Okay. Now, it's very powerful programming tool to do multiple tasks at the same time. Okay. Now, so this we have seen it. Okay, you can go through on your own at the end. Okay, so now we'll directly jump into the programming part. How do we create a thread? Okay, so in Java, how do we create a thread? Control X. So to create a thread, okay, to create a thread, we use the class pre-existing class thread. Okay, so there is a class thread. So there is a class thread. We will extend this class thread, okay, to implement the multi-threaded programming concept. So how do we do it? Okay, the syntax is we have to use the class keyword. Okay, my thread is the name of the class. Okay, and extends. So I'm using the concept of multi-thread. I'm using the concept of inheritance over here. So you can see over here that my thread is the name of the class that I want to have it. Instead of my thread, I can give you my own name also. Extends thread class. So I'm using the pre-existing thread class. So inside the pre-existing thread class, there is a method called run. There is a method called run. So that method has to be overridden. Okay. So public void run. So this is the signature that is already used in the thread. So I'm simply overriding it and replacing its content by new code. Okay, by new code. So I can have it any of the code I can have it. So say for example, if I want to have it, for example, for okay, uh, int I equals to 1, okay, semicolon, I is less than equals to 10, semicolon, I plus plus, and then simple SOP statement, okay, semicolon, then you can display the value of I. Simple. This is a very simple one, okay, that I told you. Now now, so this is how you create the thread. So I repeat, to create a thread, okay, you have to extend the thread class and override the run method of the thread class with your new code, new implementation part. So this is the first step. Now, to once you create the template for the thread with your own one by writing the instruction inside the run method, you have to create the object. Okay, so to create the object, you all know how to create the object. So my thread is the name of the class, and say for example ob is the name of the object. Okay, and new my thread and parent my thread and parenthesis. So that's how you create the thread. Okay, sorry, that's how you create the object of the thread. Now to invoke this run method, you have to use, or you have to take help of the start method. Okay, so ob dot start, with the help of which this run method will be invoked. Okay, ob dot start, with the help of which the I've written new, yeah. Okay, so to invoke this run method, now once you have created the object of this class, you have to invoke the run method if you want this thread to run. Okay, so to run that method, you have to use ob dot start. So it will automatically invoke the run method and start executing this for statement, etc., etc. Okay, so that's how the thread, you can create it and then execute it. Now I'd like to give you the example for multiple threads. Okay, uh, okay, this is what I have covered it. So just to give you a recap, we can create a thread by extending the thread class and overriding its run method, okay, with our code that we want to execute it. Now thread can also be created. This is one, whatever that I have told you just now in this example is one way of creating the thread. You can even create the thread using the runnable interface, which I'll discuss after some time, after a few slides, right? Now to create a thread, you can use this syntax, and to create the object of that corresponding thread, you can use the syntax and then invoke the start method to execute the run method. Okay, so this is an example. So in this example, I've created three class A, B, and C by extending the thread class and by overriding the run method of the thread class. Now in this example here in the PSVM part, I've created three different threads: A thread, B thread, and C thread. Now all of these thread will execute parallel irrespective of each other, right? So this is how it's work. Okay, now you can see one more example over here. Okay, so there is a class A thread extend thread class void methods SOP, some instruction you have written over here that will be executed, and here same is copy pasted out there, but it's in different class. You have created two different thread A1 and B1 of two different class A and B respectively and invoked it. Okay, now you will see how this CPU will execute, how the CPU will execute this instruction. So it's very interesting to see how this SOP instruction will print. Okay, it's very interesting to see. So until unless you don't type it and execute on your own, you will not able to see it. Please do type this instruction and see the output. It's very interesting. So whether so the possibility, what are the possibility out of output? So you might get that initially in the output screen, you might get it from class A, from thread class A, one to from thread class A, I from thread class A, uh, 2 from thread class A, 3, like that way, 1 2 3 4 5 6 with values, different values of I in a loop. It will get it. After that you may get B's part, or you may get interleaved fashions also. So which fashion you will get is very interesting to know. So until you don't type it, you're not able to see. But somehow or the other, if I give you the output over here for this program, you might get confused because currently when I execute it, it is giving a particular fashion, but when you exit it will give in different fashion. Okay, so some randomness is used out here to how CPU will be allocated during the runtime of the program. Okay, so that's the main difference. Okay, that's the objective of not giving the output over here. So it's very interesting to see if you type this code and then execute it, okay, and see the output, analyze the output. So this is one way of creating the thread, right? Okay. uh, so same thing over here. I've written threads are implemented in the form of the object that contain the method run. Run method should be invoked by an object containing thread. This can be achieved by the thread object and initiating with another method called the start, which I will cover it. So there are two ways of creating the thread: by extending the thread class or by implementing the runnable interface. So now let us talk about the runnable interface. Runnable interface is also very same. So only difference is like instead of extend, you will be using the interface. Okay, implements runnable. Okay, so I'll show you the example directly. So implements is, I told you that instead of extend, you will use the word implement. So class variable name or the class name at implements runnable. Okay, so I'll just write on the first statement. So for, okay, so to implement the to work with the thread using the concept of runnable interface, so how do you create it? So you use the word class my thread implements. Instead of extend, you'll use the word implements. Okay, runnable is the name of the interface, and inside runnable also there is a inside runnable interface also there is a method called run method. Same method, same. Okay, similar to this. Okay, so there is a method called run method which you need to override it. Okay, which you need to override it. Okay, so public void run. So public void run, and inside the run method you can give your own instruction. Okay, you need to override it. So that's the basic procedure for creating the thread class using the runnable interface, and for creating the object, the procedure is same. Okay, for creating the object, the procedure is same. So copy paste over here. Okay, so my thread ob equals to new my thread ob start. So the procedure is same. Okay, so that's how it works. Okay, again, until as you don't type it, you'll not able to understand. Now let us now check the different stages of the thread that our thread undergoes. So there are basically 5 different stages that a thread undergoes. First one is your new. Okay, then a kind of runnable, runnable, then okay, running running then blocked, then fifth one is exit or dead. Okay, so whenever you create a thread, so maybe you have been created an instance my thread ob equals to new my thread, then at that time it's called a new thread. It is in a new state. The thread is in a new stage of its life cycle. Okay, so a thread will undergo this life cycle 1 to 5. Okay, so whenever you create it, it is in the whenever you create it, it is in the new state. Okay, then after that you will be invoking ob.start. So when you will invoke this ob.start, basically cpu has to assign to it. CPU is a processor, but CPU is very busy entity, so it might get engaged with some other task and all, so you might not get the immediate attention of the CPU, so you must have to wait. So at that point of time means once the instruction ob.start is invoked, cpu may not be immediately available for execution. So at that point of time, the thread is in the runnable state. It has to wait for cpu to become free. Now once cpu becomes free, the instruction given in the run method will get executed. At that point of time, the thread is in the running state. Okay, the thread is in the running state. Now during the execution, the thread might get blocked, okay, due to some reason, maybe IO input or any other system call and all. Okay, so at that point of time, the thread is in the block state, and once the thread task is completed, the thread will be entering into the dead state. So that's the basic things. Okay, so now block state may be of like there are various reasons for thread to enter into block state. So it might get sleep. Okay, so you must have heard about the sleep command, sleep 1000. So if you write somewhere in the program, if you write down somewhere in the program, suppose you write down SLEEP, okay, and 1000. So for 1000 millisecond, this thread will enter into a sleeping mode. Okay, this is one region, sleep mode, blocked for a specified time, 1000. So suspend. So a thread may also enter into a block state whenever it gets suspended. So maybe by executing the suspend command, etc. Okay, any system call. So now block state until further orders. So it will enter into block state until further orders. Okay, maybe invoke, revoke, or wake up kind of thing. Okay, next is the wait state, block until certain condition occurs. So like for example, until unless the programmer presses the enter key, okay, don't become awake or don't enter into the runnable state or don't resume it. So from the block state to runnable state, these are the system call that may be invoked, like maybe notify or resume. Okay, so that may happen to revert back from block state to runnable state. So these are the list of the stages or the states that a thread may undergo during its life cycle. So and the last one is dead. So whenever and stop or the task of the thread gets completed, it enters into the dead state. Okay, I'll just read it out so that, because I have not used the technical terms. So okay, the thread is in new state if you create an instance. You instance means using the new keyword of a thread class, but before an invocation of start method. Runnable. The thread is in runnable state after the invocation of the start method, but the thread scheduler has not selected it to be a running state because it might happen that CPU is busy. Okay. Now then the next one is the running. A thread is in the running state if the thread scheduler has selected it. If the thread scheduler has selected it, means CPU is assigned to it. Okay. Next is the block non-runnable. Block state is also known as a non-runnable. Okay. This is the state when the thread is still alive, but means that the task is not completed yet, but is currently not eligible to learn. Maybe preventing from entering the runnable state due to some reasons like somebody have invoked the sleep, or somebody have invoked the suspend, or have wait. Okay, have to wait. The last one is the dead state. A thread is terminate a dead state when the method when its run method exists. Okay, so whatever that you want to execute by the thread, you keep everything in the run method. Now once run method instructions are completed, now thread will enter into a dead state. So that's the different stages of the life cycle that a thread undergoes. Okay, now coming to the point priority. So priority, suppose there are some threads like maybe a green color. Suppose there may be a black color thread, and there is a red color thread. Okay, and there is a green color thread. Okay, and there is a blue color thread. Suppose there are four threads. Okay? Now suppose you want, while executing the program, you want this red color thread to be executed first. So you have to set the priority, you have to give the importance to this thread. So to give the importance to this thread, you have a functions called like set priority. But if you don't give any of the priority level also, so by default it is 1. So the range of priority value that you can have it from 1 to 10. So by setting up the you can set the priority by invoking the set priority method, by invoking the set priority method. So name of the object dot set priority, inside bracket you can specify the number, or you can use this, you can use this. Okay, max priority, min priority. Okay, and then accordingly you can invoke the start method. Okay, so here in this case, the a1 object, a1 thread has been set as a minimum priority, so it will not get executed. But before that, this one b1 will get executed because it has been set to max priority. So when you see the output, the instruction of b1 will get, you will see. Okay, so again I'd like to show you that until you don't execute it, you'll not able to see the importance of this instructions. So just to give you a brief about it, so a thread has a priority. By default, the default value is 5, so all will be treated equally. But however, if you want to increase or decrease the value, okay, increase, lower, suppose you want to lower the priority of particular thread, and you want to increase the priority of particular thread, then you can use this value. Okay, so you can set the value using the, so you can set the priority value on of the thread by invoking the set priority method. The example is shown over here. Okay, now during the execution, see, every threads are running parallelly, concurrently executing multiple instructions. Okay, now I'd like to give you very important issue pertaining to parallel execution. Okay, suppose this is a memory. Suppose this is a memory, a single memory, and there are two program. Okay, or there are two thread. There are two thread. This is a memory. Okay, there are two thread, T1 and T2. Now we all know that T1 can execute parallelly and T2 also can execute parallelly along with each other. So this is a time frame. Okay, this is a time. Time. This is a time. Now say for example, at time t equals to 5 and at time t equals to 5 by t1 and t2 both respectively, both are trying to access the same memory location. Maybe this is a bank balance. Okay, bank balance, your balance. So you always want your balance to be accurate as possible without creating any instruction. Now t1 is decrementing 5,000, and t1 is decrementing 5,000, and T2 is incrementing 5,000 to the already existing value, say for example X. So decrementing. So decrementing what? Decrementing 5,000. Here, incrementing or increasing 5,000. So now what will happen? How this execution of instruction will take place, because both of them have tried to access and modify the content of this memory at the same time. So it leads to a data inconsistency problem, and an ambiguity data may and ambiguity result may arise. So to avoid this, synchronization is needed. To avoid this scenario, synchronization is needed. So I hope I have made it clear the need for the synchronization. When both the threads which are executed parallelly try to execute the same resources, so data inconsistency may arise. Okay, so to avoid this problem, we need synchronization. Okay, so memory is an example of resource. So synchronization in Java is the capability to control the access of multiple threads to any shared resource. I'm assuming that both threads can access this memory. Okay, also I already told you that memory is shared in the threads. So when two or more threads need to access the same resource, they need some to ensure that the resources will be used by only one thread at a time. So here what will be the problem? Okay, so how it will be handling? So that is handled basically with the help of the synchronization. So there is a method called synchronized. Okay, as you can see over here. As you can see over here, there is a method called synchronize. With the help of which synchronization is done, right? So synchronization is done. As you can see over here, you have created a1. With the help of the object a1, a2 and a3 is created with which in which both have the access to print. Okay, and it will get start. Okay, over here. So how this will get executed, and this how this will get executed. Okay, that's matter of choice. Okay, so or you can type it and then again execute these two instructions. I'll leave it up to you. Okay, I have told you what is the need for synchronization, what will be the problem, so you can try it on your own. Okay, I hope I'll be making it clear. Okay, that's all for today. Thank you so much. So just to give you a brief about it, so we have just covered the thread chapter. Okay, we have just covered the thread chapter. During the thread, while covering the thread chapter, I have discussed the basic difference between the program and the process, single process system, multi-process system. I have talked about what is multitasking and what is the meaning of independent computer statement, and I have given you difference between the process-based multitasking and thread-based multitasking, and what is a multi-threaded programming, and what is the importance of multi-flow of control. Okay, so and then we have discussed about the basics of thread, lightweight process, multiple flow of control, runs parallelly, shared resources, lightweight process, etc. Okay, then I've shown you the highlights of multitasking and difference between multitasking and multi-threading. So I'll just read it out one or two difference. So it is an OS concept, operating system concept, in which multiple tasks are executed simultaneously. Okay, it is a programming concept in which the process or a program is divided into or more subprograms or threads that are executed at the same time in parallel. Okay, so there is a difference between them. So you can see over here that the main advantage of multi-threading program is it has got multiple flow of control. That is the main. There are a lot of other difference like high efficient, low efficient, helps in developing efficient OS, helps developing efficient program, etc. You can have a look on it. This is purely theoretical. Okay, then after that we have seen how to create the thread in Java using using the thread class, or by extending the thread class, or by implementing the runnable interface, and by overriding the run method of both ways, extending thread class and implementing the runnable interface. Okay, so these are the examples also we have discussed. Then after that we have seen the life cycle. Okay, a newborn, runnable, running, block and dead state. Then after that we have discussed the how to meaning of priority, and how can we set the priority, and what is default values for priority, and what is the range of priority values that we can have it for scheduling. Then after that we have understood the basic concept of synchronization and the need for the synchronization, and have given you in your hand the example of the synchronization so that you can execute. Okay, and see the output accordingly. Okay, thank you so much.